All right, here it is. Here's the big rule, L'Hopital's rule. So we're investigating the limit of a quotient, limit of f of x over g of x as x approaches a. And again, we're writing this out for x approaches a, but a similar rule exists for, right-hand limits, left-hand limits, x going to infinity or minus infinity. All right, so we're calculating the limit of a quotient here. And if we find that it's an indeterminate form, so 0 over 0 or infinity over infinity, what we can do is we can apply L'Hopital's rule. And what it says is that this limit of the limit of f of x over g of x is equal to the limit of the derivative of f divided by the derivative of g. So we can essentially kind of apply the derivative to the top terms, apply the derivative to the terms in the denominator there, and then calculate the limit of that. So why is this helpful? Why throwing in derivatives here? Why is this going to be helpful? Well, derivatives a lot of times kind of simplify a function down in some way. So what we're going to see, not always, but a lot of times, and what we're going to see is this limit, after we do the derivative, is going to simplify the fraction down enough where we'll be able to calculate it with kind of normal algebraic means. So this is going to be a really handy tool for calculating these more complicated limits. And we want to do this in steps. So the first step, whenever we're presented with the limit of a quotient like this, the first step, we need to verify, before we do anything else, we need to verify that it's of one of these two forms. We can't just use L'Hopital's rule on anything. It has to be 0 over 0 or infinity over infinity. If we just start applying L'Hopital's rule all over the place, we're gonna run into issues. So this rule only works if this original limit is either 0 over 0 or infinity over infinity form. If it's something else, then we're gonna get something wrong. So this only works for these indeterminate forms. So that's the first step. We have to verify, we have to check that we have the correct indeterminate forms, 0 over 0 or infinity over infinity. And then once we do that, we're going to apply the rule, and we just want to kind of note where we actually apply the rule. So in our work, we're going to be going along, and we'll see that we have one of these indeterminate forms. And we just want to make a note of where we actually apply the rule. So the common way we do this is we put a little h, or if you want to be fancy, put a little L apostrophe H above the equal sign. Or if you actually want to write it out, L'Hopital's rule, also fine. But we make a little note where we actually apply the rule. All right, so that's kind of the two preliminary things here. And we'll see how we actually apply this. So calculating the limit of f of x over g of x, we're going to, if it's of that correct format, correct indeterminate form, applying the rule allows us to look at the limit of f prime over g prime. And you just want to make sure, we're talking about quotients, we're talking about derivatives, so you want to make sure, it can be kind of easy to do. You don't actually confuse L'Hopital's rule with the quotient rule. These are two very different things. So L'Hopital's rule, L'Hopital's rule is for limits. Quotient rule is for actually, let's say L'Hopital's rule is for limits of f of x over g of x. And quotient rule is for doing the derivative of f of x over g of x. So very different thing. So L'Hopital's rule is used to calculate the limit of f over g. Quotient rule is used to calculate the derivative of f over g. So these are very different rules. Quotient rule is just for calculating derivatives. L'Hopital's rule is when we're calculating, we can use it sometimes when we're calculating limits. All right. Let's see some examples.